Hi friends, welcome back to the course. In this part we'll be creating a magical fireball effect using pyro simulations. We will start by setting up the essential attributes and learning how to modify them with noise values for more dynamic and interesting results. Then we will put the techniques that I covered in the previous lessons to a test and use them to shape our fireball, giving it the motion and the intensity it needs. And finally, we will take a quick dive into Solaris, setting up a render with Karma to bring our effect to life. So let's get started. Now let's add in a sphere as a source object here. And I will just make this a bit bigger to 1 meter in radius, and then I will change it to polygons and increase the subdivisions a bit. And now it's time to create our sources. So let's add in a pyro source. And I want to initialize the burn attribute, the smoke attribute. So we have burn, temperature, and density. And I also want to scatter points on the surface because I actually want to turn the surface of this sphere into a magical fire. Now let's take a look. We have our attributes on our points. That's good. And now we can just rasterize these. So let's use a volume rasterize attributes node and rasterize all of these attributes, the burn, the density, and the temperature. And now we will just add in a pyro solver. And let's copy the voxel size here and link it to this voxel size by choosing paste relative reference. Now these two values are linked. And we already have a very basic pyro simulation. In the last part, we went over very important settings, so nearly all the settings of the pyro solver. But I did not show you how you actually can manipulate your source attributes and what kind of an effect this can have on your simulation. But this is actually something that is very powerful. So let's take a look at that. To make this simulation more interesting, I want to change my source attributes. Let's visualize the burn attribute for now. Right now, the attribute is set to 1 for all of the points, as you can see here. So here we have burn, it's just a value of 1 on all the points. But we can, of course, add some variation in here. And therefore, we can use an attribute noise. And in this case, we want to use the float version because these attributes are float attributes. You can, of course, also do that with an attribute adjust float node, or you could also use a warp or whatever. So if you already watched the part about attributes in the basic course, then you should know a little bit about that. But I want to use this attribute noise node because I did not use that yet. So let's change this attribute to burn, because we want to manipulate our burn attribute, and I will activate it now. And instead of adding to this, I want to multiply it with our noise value. The noise pattern here is a little bit too big, so let's change the size here and let's set it to something like 0.4. Let's see, that looks a little bit better, maybe even a bit lower, 0.3. And we can also remap that a bit, so let's enable the remap and let's just add in some areas where the value is lower. Now we have a bit more contrast in here. That looks quite okay. Let's make sure that this is on 0 though, like so. And now I can also animate that. So just activate the animation and set the pulse length to 0.5. Let's activate our real-time toggle here and let's see how fast this moves. And yeah, I think that this could work. But I also want to manipulate the other attributes. So let's hold down Alt, left click and duplicate this node. And let's also manipulate the temperature in exactly the same way. So I'll put this in here. And now I also want to do the same for the density. So let's also create one version for density. Let's put it in here. And now let's just offset these, that they are not in the same pattern, so that they just look a little bit different. Now we can turn off our visualizer and see what this does with our pyro simulation. So let's revert back here. Let me quickly change my viewport so that we have a dark background. And let's take a look. Now this should already look quite different. And you see that there is some variation now in my simulation. Of course, I don't have a lot of details in here because my resolution is very low. So let's just add a bit more details to our simulation. And you see now that this has an influence on my source here. That's pretty good. Now, my goal here is to create some kind of a magical effect. So let's see how we can do that. First of all, I want to change the look of my fire because I want to create a bluish magical fire. So let's go to the look and just change this color here. And let's set it to blue. Now play a little bit with the values. Something like that maybe could be nice. Now we have a nice bluish fire going on here. And now I want to focus actually, first of all, on the flame. So let's go to my sourcing and I will turn off the density for a moment so that I have just a flame going on here, as we can see now, because then I see the details a little bit better. And right now, I think that the buoyancy is too high. So you see that the flames are rising quite fast. And if we let this run in real time nearly, yeah, it's rising quite fast. So I definitely want to reduce the buoyancy a bit. So let's go in here and set it to something like 0.5 maybe. And let's see what this does. That looks already a bit better. And I also want to use the advection reflection. So let's add this in here with a single project setting. And I will also increase my cache here a bit so that I have a bit more space on my RAM. Now let's revert back and let's recalculate this. And now we already get a bit more details here in our simulation. That looks not too bad. Before I do anything with the shape, I want to show you another method how you can improve the quality of your source. So adding these different noises to the base attributes already changed something here. But if we add a velocity field, we can make this even more interesting. So let's take a look how we can do that. I want to create a velocity field based on my sphere. So I will branch off here and add in a mountain node. The mountain node just displaces an object based on a noise, as you can see here. And let's actually set this up in a bit of a different way. I want to create another pattern here. So because this should be a magical orb, I want this to actually have a certain direction. And instead of just changing this size as it is here with the slider, I can also split these. So now I have access to the X, Y, and Z axes separately. Now I want to reduce the size here on Y, and this will create these shapes here, as you can see. And now I also want to animate this. So let's add in an animation, maybe let's say 0.5. Let's take a look what this does now. This doesn't look too bad, but I also want to offset that. And I want to offset it along the y-axis so that these waves here travel through my sphere, let's say in an upward motion. So let's take a look how we can do that. And there's this offset. And here I also can separate the axes. And now I will just put in a value here like time. Actually, I have to write at time to use this attribute. And let's say time times 5. Let's take a look what this does. And I think that this could be pretty cool. So this is a very nice setup, and I want to create velocities from that. Let me actually go into the fractal and see whether we can improve this a little bit. Maybe add a bit more roughness here to add a few more details. Yeah, that could be cool. And let's see the amplitude. We could also increase this slightly. Yeah, let's do it like that. And now I will turn this into a velocity by using a trail node. And usually you use it, as the name says, to create trails. But you can also change this here to compute velocities. And if I visualize my velocities now, you will see what that does. Now I have a velocity field that looks like that. So we create different velocities that are running through our object. I can turn these velocities now into a volume. So let's just take this volume rasterize node here and duplicate it because this is already linked to my voxel size. The only thing I have to do is to change this attribute input here to velocity. And now I have my velocity field. The problem with the velocity field is that the particle scale is too big. On the volume rasterize, we don't have that problem, but when you're working with vectors, I think that this is the reason why this is a problem. So let's just turn this down to something like 0.1, and now we have a nice representation of our velocities. Now we just have to merge these two volumes here, and let's merge these, and now we can feed it as it is into our solver. Now let's revert back here and let's take a look what this does with our simulation. And you immediately see that I get a bit more motion now here down at my source. So it is a bit subtle because under sourcing, this source scale is set to 1, but I can set it to 2, for example, just to make it a bit more obvious. And then we will see that now we have a lot of energy and motion on our source. And that actually looks already pretty cool. And also our flames now look way more interesting. Now, it would be interesting if I manipulate these attributes over here in a similar way as I do with the mountain node. What I can do now is I just copy this elemental scale here. So let's copy this value. Let's go into our attribute noise float. And here I can do exactly the same. So I can just split these axes here and then right click and say paste relative reference. I will do this for all of these nodes now. So paste in the relative reference. And let's do the same here. And right now, let me actually take a look how these look like now. Yeah, I think that this should be fine. This should not have any effect anymore. Or actually, I'm taking a look at my burn attribute, right? Yeah. So I have to do these changes at the burn. So let's take a look here. And yeah, that looks good. If I take a look at my size, yeah, that looks nice. So now I have a nice pattern here. And I also want these to move in the same way as this does. So I also have an offset value here, as you can see, that I can also separate. So let's do that. I'm still on the burn. Let's separate this as well. And now we can just copy this. Actually, we can, yeah, let's just copy this parameter and paste it in as a relative reference, because then I can just change everything on this mountain node and I don't have to care about this. What we'll do here is just copy the relative reference in here and keep this offset value here to 10, then this should have another pattern. And we will do the same here and just copy this relative reference in here. And now let's take a look what this actually does with our pyro simulation. Now we get a pretty interesting motion here on our sphere, as you can see here. And this will be even more obvious later on when I'm setting up a shader and rendering this. Okay, so far so good. So now we have a good basic simulation going on here. Let's take a look. So for a magical effect, I think that my flames are just a little bit too big. So let's go to our fields and let's reduce the flame lifespan maybe to something like 1.5. Then I could also add in now a little bit of smoke. So let's go to my sourcing and let's enable my density here. Let's check what this is doing. Now we will add a bit of smoke to our simulation. That looks actually quite cool. I think that it is a little bit too much, so I will set this down to 0.5. I only want a little bit of a wispy smoke, and now under the fields, I will just set the dissipation a bit higher, maybe to 0.15, so that this will dissipate a bit earlier. And yeah, actually that looks pretty nice. The other option that I have, and I don't know whether I showed you that in the last part, but I can also add density to my simulation from my flame. So I can activate this here. And now I will add in density to my simulation based on the values of my flames. This can also be quite handy, especially if you're creating a fire. But for this kind of magical effect, I won't do that. Now, let me take a look at my viewport settings, because somehow I don't see enough detail here. So I will go to the texture level here and see whether I can improve that a bit. So if I increase the resolution here, Let's see whether we will have more details in our viewport. So we'll just change the 3D texture limit here and then set it to full HDR. Let's see whether this makes any difference. Actually, no, it does not really make a difference. Yeah, I see a bit more detail, I think, but I have to zoom out a bit. The resolution of our simulation is still not that good, but for now, I'm happy with it. So let's now work on this shape of the flame, and therefore I will go to the Shape tab now, and we can add in some turbulence. Let's add in some turbulence here, and I will also activate the visualizer here. Let's open up the settings and let's take a look what we can do here. So right now the control field is set to density. Let's recalculate this, that we know or see what's going on here. And I actually think that this looks pretty cool. So we have a slight effect here on the sides here. I could increase the strength a bit to 0.75, maybe reduce the size slightly to 0.6, so that we get a bit more of smaller effects here. And now let's take a look whether we can remap this a bit better. Right now we are using our density, but I actually want to use the flame here, I think. Yeah, because then I get these a bit closer to my flame here. And we can compute the range. It should be somewhere between 0 and 1, so let's just leave it like that. And now I could change this field here to hill, and I think that this could be quite nice. So let's take a look what this does now. And yeah, this is now creating a lot of swirls that are actually nearer to my sphere here. And I think that this looks pretty good. There's another thing that I could do that probably would look way better, and that is if I let my simulation collide with my source. So as I showed you before in the last part, we can use a collision source node and just plug in our sphere here. And now I could just merge these two streams together, or the two outputs here. And on the one hand, we have the geometry, and on the other hand, we have a VDB. The geometry also contains the velocity. It's actually not necessary in this case, so let's not do that, Let's just cut this. We don't need a merge here. We just have to use this VDB here, and we can come to our collision tab and now change this to SDF and volume velocity. This should be totally fine for now. And now let's rerun the simulation. And yeah, that definitely looks way better. But now we lose a little bit of the flames, as you can see here. So through the collision, we lose a bit of the flame height. And maybe this has also to do with our turbulence. So let's turn this off for a moment just to see what influence this has. Actually, it's not the turbulence. Maybe it is really just the sourcing and also the buoyancy. So let's increase the buoyancy again to 0.75. And let's go to the sourcing, and under flame, let's add in a bit more here. So I just double the value here to add in more flames to my simulation. And now let's take a look. And yeah, I think that this actually looks pretty cool. Nice. So now let's take a look at the shape, what else we can do here. I don't think that I need any disturbance here. I don't want to add any more small details in here. I could add in a little bit of shredding. That's fine. Maybe let's set this to 1. And flame expansion, I could use a small value here like 0.25 or something like that, just to add a bit to the flames here, make them a tiny bit bigger. This could be quite nice. And now I definitely want to add some viscosity, and I will set this to quite a high value. I mean, 0.1 is not high, but it will have an effect on our simulation. If we take a look at that, it will smooth it out quite a bit, but should increase the magical effect here. And yeah, actually, this doesn't look too bad. So I really like that. I can turn off my turbulence guide here. So let's turn this off. And let's take a look what I have here. And it's always difficult on the simulations to really judge the speed. Even if I'm rendering this to the RAM, I will probably not get a real-time feedback. Let's take a look actually what we get here. So let's go to the guides here and let's draw the FPS on screen. Now we can see which FPS we achieve. And actually it is real time. Okay, this is surprising. So we can definitely check that out. Sometimes this does not work, but for this it does. That's good. So let's render a few more frames so that we get a feel for this simulation. Let's take a look. And yeah, I think that it actually looks really cool. The only thing is this velocity is a bit too high, in my opinion. So let's go to sourcing and I will just reduce it to 1.5. So just remove a bit of the velocity on our source. And yeah, that looks definitely a bit better now. Awesome. So let's say that I'm satisfied with my simulation now and that I want to cache this to disk. And there's a pretty cool option here under the quick setups. If you select your Pyro solver, you will find these quick setups in here. And here you have a lot of shortcuts, more or less, how you can create some settings here. And what I really like is actually to add in an optimized export. So you can just click on that and then you can go under outputs and you will see that a few options are now added in here. So if I just put in the standard Pyro solver, I just will put it beside here that we can compare these two settings. And if you go to the output, so this is the original one, that is the setting if you don't change anything. And then I changed this to optimize export and you see what it did. So first of all, it converts it to VDBs because these are a little bit easier to calculate and don't have that much data. Then you see that it also uses only 16-bit float for the resolution of the volume. And then it also resamples the velocity. So these are all the settings that it changed here, as you can see. And that is pretty handy. Now, if I want to cache this now, I can also go to a quick setup and I can say cache simulation. There are a few bunch of other options and you can try these out, if you want, but I will just use this cache simulation now and it will add in a file cache here. Let's get rid of this Pyro solver. I don't need this. So before I really cache this simulation to disk, let's actually take a look whether we want to do any changes. I definitely want to reduce the voxel scale a bit so that we have a bit more resolution here. I may want to go to 0.03, maybe even to 0.025. Let's take a look. Yeah, that looks quite nice, but I want to go a little bit further down to 0.025. And maybe I also want to increase the time scale a little bit to make all of these motions a bit faster. This could have a nice effect. And yeah, let's take a look. I think that this is a really good result. We will get a lot of nice detail here in this simulation. That looks really cool. And now I'm happy and I will cache it to disk. So I will just choose the disk cache now and go to save to disk and I will be back when this is finished. Okay, so my file cache is finished. It took about nearly 3 minutes to save this to disk and it has about 1.5 gigabytes on the disk. So using this option here on my Pyro solver to optimize the output definitely makes a difference. So if you don't do that and just save it as it is, it would definitely have, I don't know, double or even way more disk space. And now it covers only 1.5 gigabyte. So I think that the resolution is quite nice. Now let's take a quick look how we can render this. And I want to bring this into Solaris. We didn't talk about Solaris yet in this course. I will cover Solaris in detail in module number 4. But for now, I want to show you how you can really quickly set up a render for these Pyro simulations, because sometimes this is a little bit a mystery for beginners, how to render Pyro simulations, but it's actually pretty easy, especially with these little helpers. So now we select our Pyro solver again, and under the quick setups, you also have this option to create a render stage. So let's just click that. And then you have some choices here between default, daylight, sunset, sunrise, whatever. I just used the default one here. And what this will do is it will create a whole scene inside a lob network, so inside Solaris, as you can see here. Now, let's take a look whether it imported it correctly. And right now I cannot see anything, unfortunately. So let's turn off our renderer. Let's see where we are here. Yeah, here it is. So it imported our solver, but if we go back to our geometry network, let's take a look what happened here. So Houdini actually created this LobNet, that is the Solaris environment, and it also added this output null, which is referenced in our LobNet. But I actually want to connect this to my file cache. So let's just change this right here. And now we can go into our LobNet and take a quick look what Houdini did here. If you don't know Solaris, as I said, don't worry, we will cover it in part number 4 or in module number 4. But for now, let me quickly go through this setup here. So the sub import just references in our null object, so the result of our simulation. Then we have this render geometry settings here that just sets up some parameters, for example, that it enables motion blur for the simulation. And it also says that this should be treated as a light. That is pretty handy because then it will emit light. Then we have a material, and inside this material, you can also find a pyro shader that is already set up for us. We have some lights in here, a camera, and karma render settings. So this is just a quick overview what we really have here. Now I can, of course, just scrub through my simulation and I see the result in here. Let's turn off this grid for now. What I want to do is I want to add in a floor because then we have something to reflect our nice magical sphere. This would add a bit more detail. So let's add in a sub create quickly. And I definitely don't want to go into any detail now of the Solaris workflow. I will just do that quickly. You can follow along or not. If you want to get a quick introduction to Solaris, I actually have a basic introduction to a simple workflow on my YouTube channel. You can check that out. But as I said, in module number 4 of this course, I will explain Solaris in a bit more detail. So let's just add this in here so that we have something to reflect. And now I will go in here, quickly create a karma shader here and rename this to my floor. And I just want to make a dark reflective material here. We'll do this pretty quickly now, just something nearly black. And specular is fine. And we can make this a little bit metal. And now let's actually add this to my floor. I will just do it like this, rename this to floor and autofill the materials. Now I have all the shaders in here. I'm just interested in this floor one here. So I will take my geometry spreadsheet that should be open here and drag the floor now into this geometry path here. And this is now added here to our scene. Okay, so far so good. Now I can go to my Karma XPU or CPU in this case and start a render, as you can see now. So we have these lights in here and we can turn these off. We can also turn off the dome light. Then this will look a little bit more interesting in my opinion. And I somehow lost the color from my shader. But if we enter the material library and take a look at the pyro shader under fire, the color is actually here. What is happening in here is that somehow this pyro preview shader for the XPU is overriding my color. I don't know why, but I can just deactivate it. And then I will be back to my original settings here that I set up on the pyro solver. And now I will show you a little trick how you can improve the look of your simulation quite dramatically. It has to do with this intensity ramp here. So if you create another point in here, and it doesn't work because this is actually overwritten. So let's right click and let's say delete channels. Now we should be able to add in points. Yeah, we are. And I will just create this kind of a triangle shape and bring these together a bit closer. And you will immediately see what this does. We are now filtering out certain elements of our flame field. So make sure that under bindings, under fire, your flame field is active here. This is important. And now we can just grab all of these points and start dragging them around. And that way we'll filter out different areas of our fire. And I think that this looks really cool. So this is really a good way of creating these flames here and really extract a lot of detail out of this simulation. If you want to add in more, then you just add a point here with a value of 0. Select this point here and let's add maybe 0.1 here. And then we will get this nice glow here. You see, we'll add in a bit more details here, and we can now see a few more flames coming out of this. If you want to increase the overall intensity, you can do that. Let's see what this does. If we set this to 50, then our fire gets way brighter. This is way too much here, so I would set this to 25. And of course, we also have our smoke in the scene. And if you increase the density here, then you will probably see it. Yeah, we can see a little bit of the smoke here. It's not that obvious because I turned off the lights. So let's go back in here and maybe activate this one light here, the distant light, set it to a value of 2. This should make our smoke a little bit more visible. And yeah, that's actually it. You know, we have a motion blur going on. This is already set up, and this is very important for fire rendering. Now let's take a quick look how we can extract the fire here to render just our flames. But let me actually also bring up my floor a bit so that it is closer to my ball, to my magic fire here, so that we have some reflection in here. And if you just want to render the flame, you can go to the camera render settings. And yeah, there's one option that you just go in here, go to the pyro shader and turn off the smoke. So this will only leave the flame here, but you can also render this on a separate path by going to the render settings. And because it is actually set up as an active light, we can now go to the lights and emission, and you can choose this visible light setting here. So if you activate this and now go to your render outputs and activate visible lights, then you see that we have only the flame now on a separate render path. And this can sometimes be very helpful when you want to create a composite. Cool. So in this case, I would just go to my render settings. I would actually increase the resolution here of my image, and then I would be ready to render this out. This was only a very small introduction how you can set up a very quick render for your pyro simulations in Solaris. That's it. In the next parts of our course, we will take a look at flip fluids. So thank you very much for your support, and I really hope to see you soon. Goodbye.